Okay, we're going to look at chapter 8 in the textbook on interface segregation. It's getting towards one of the final chapters. The last three chapters all are a case study on that we'll be using as possible final project. So we're getting close to the end of the new material here. So let's look at this chapter 8. So interface segregation is a relatively simple concept and not that hard to implement. So, as it states in the textbook, it's really a principle that interfaces should be small and not overly complex. You shouldn't stick lots of things in an interface. Instead, you should have multiple interfaces and possibly implement those. We'll look at a CRUD example. If you remember, like from database modeling, CRUD is create, read, update, and delete, and it's a common set of actions you will have to perform on like a database or something like that. Create a record, read a record, update a record, or delete a record. So we'll look at a kind of a generic version of this. And initially we'll start with an interface that has all these things in it. It has a create, a read one record, read all the records, update, and a delete methods in it. And the textbook describes this as an create, read, update, delete. I think we'll look at code for a second. In a second, I think this will be abbreviated CRUD in the code itself. And then the textbook goes through and argues why having all these things in one method isn't the best. So here's an overview, but here's the actual code for the interface here. And here's our create, read one, read all, update, and delete. Let's go over a little bit of the types. Again, this is a generic or templated method. That's what these greater than, less than signs do. We haven't done too much in that, so let's just quickly review that. So this is a type of entity. Often these are just abbreviated as a T in code. Your textbook likes to use the word T entity here. But you can put whatever word you want here, and it is just a placeholder for some type, like an integer or a person or a class name or primitive type. And then throughout the definition, that whatever you put in here will be used in other places. So whatever type when you later on create something implementing the interface and specify a type here, it'll be used throughout this. All these T entities will be placed with that type. So you can just think of this T entity as a generic type. And again, often you'll see these just written as a T in other code examples. So like read one will return one of these entities. Create, you're given an entity. Read all returns a list or a collection of these, and they're using this generic IEnumerable list that could be an array or a list or any sort of collection like that of these objects. The only other thing is this GUID. In Microsoft, they have a generic unique identifier. And so they have a method of creating these unique identifiers. And so this just assumes that you're going to be using one of these unique these IDs as the ID of whatever object you're creating. And then we go through and talk about an implementation for this, and then adding some decorators to this. So one of the problems with having a big interface like this is if you're going to apply a decorator to it, you'd have to make sure you include all of these methods in that decorator. And sometimes that's not a problem, and so they talk about a logging decorator. Say we wanted to do this, use these methods, but we also wanted to log all the database access, maybe create an audit trail of every access to that. So we would create a class that would be built on top of this CRUD class. It would have a CRUD class inside of it, and it would implement the same interface. That's what a decorator does, is add functionalities to an existing class. But it would and logging would probably want to log everything. So it would have a crate, and it would log the crate, and then it would call the crate in a decorated class. Read one, again log it, and read all, log it, and then call read all in the decorated class. And so again we'd go through and we'd call the methods in the decorated class from this the logging class. So we just call the general delete method from here after we log it. And so that's not that much of a problem, because we'd want to do that. We'd want to log all the methods. Similarly, they talk about a transaction processing thing. You might want to convert this database access to transaction processing. I don't know if you got into transaction processing much in database modeling, but what it does is if you have a sequence of SQL commands and you want to treat them as one unit, you can put them in a transaction, so that if a problem occurs, you'll roll back the entire transaction, all the SQL commands in that little group. Um, and it's commonly done with complex database interactions. And all you have to do is, with the database interface, is set up a transaction scope, do your commands, and then wrap up the transaction. So again, they're using a decorator class here, and they're passing in the base class that we're going to decorate and keeping track of that. And then for all the methods, they're creating a transaction, doing the actual methods, like in the read one, they're setting up a transaction environment, calling the read one in our base class, and then wrapping up the transaction here. And they do that for all of these. And again, if you're going transactions, you'd probably want to do all of these, all the CRUD actions inside transactions. If you're doing one, you probably want to do them all. So in those cases, having it all one big interface is not a problem here. But there are times where you won't necessarily want to do that. So they talk about these cross-cutting concerns, which again impact all of the methods in our interface. But again, there will be decorators or things we want to add, functionalities that won't impact everything. So one of these might be, before you delete a record, you might want to verify with the user. Ask the user, do you want to delete this? And so you might want to add functionality onto just the delete method here. So in order to do this, they're going to shows how they'd have to do it with this big interface. So again, they're decorating, creating a delete confirmation decorator, and they're passing in the base decorator into the constructor here. But most of these methods are just basically empty. The create method does nothing other than call the base create. The read one just calls the read one method. Read all just calls read all. Update just calls update. So most of this stuff is just kind of almost useless repetition of code. The only thing where we get into any interest is the one method we want to change is delete. When we call delete, we're going to ask the user, do you want to delete? Read that keystroke. If they say yes, then we are actually going to delete that record. So this is the only one we're actually adding some functionality to it, but because the interface is one big interface and we have to implement all these methods in the interface, we have all these almost empty methods here. So that's what we're going to try to get away from, is that sort of stuff. So what they do is they're going to pull this delete method out of the interface into a separate interface. So now they have a I create, read, and update interface, and then an I delete interface. So I have two different interfaces, and now when we do this, we just have to update the delete interface. So all these methods stay the same, and then we're just going to add a decorator to the I delete thing. So we're going to pass in um, uh, some object that implements a delete, and then we just have our one method, and we're going to ask, are you sure you want to delete? And read that in and delete if necessary. So again, we're only decorating or modifying one of the methods, so we're going to break that off in a separate interface. And we're going to do that again, looking at this. And again, they do a refactoring here. I'm not going to go over that. That's better as far as not asking from the console that you're doing. Another object is caching. When we're reading in records, we often sometimes have to cache these. So we're going to read when we read one record, we might have to the read command actually might read 20 or a set number of records in and return them all at once because of the disk access requirements. And so we'll cache those. And again, often if we have them all read in, rather than going to the slow database already, we'll keep some of them or all of them in memory if we've already read them all in. And so there's this cache method, and we're not really going to implement a cache, but we're just going to talk about how that decorator might work. So again, with caching, it would only impact the reads, so the read one and the read all here. So again, what they pulled those off is their own interface. Um, oh, well, here they're showing it with all of them: create, read, and update. And so again, the create does nothing. The update really does nothing other than call update here. And we're only decorating the read one and the read all method. So they're going to pull read one and read all into its own interface called the iRead. So we've got those two methods in here. And then we only decorate those. Finally, we have this, what's the only thing that's less of is a create and an update methods. They both are basically the same, just different words here. Create, we're given an entity. Update, we're given an entity and we update that. We're going to redo this and combine these into an iSave update, so their signatures are basically the same. And creating and update a record have very similar functionality. So we're just going to have an iSave or a save interface here. So I save and then we're just going to save the record. So now this is interface segregation. We've broken our interface up into smaller parts and divided it, segregated it into individual interfaces that we're going to work with. So sometimes it's hard to kind of understand this code here. So I also have a project in Visual Studio if you want to open up that comes from the textbook that shows some of this stuff. This is the basic CRUD stuff. There's a program here. Let me move this over a little bit. And then under the CRUD project, we have the iCRUD interface. And here's we have one big interface here with everything together. And so then we have an object called basic CRUD that implements that interface here. So it implements create, delete. Now we're not actually working with the database here. So all I'm having it do is we're just writing out things, creating an empty list, or deleting a person, creating a person, stuff like that. Now you'll notice again we have this T entity here, just generic entity. So when in the main program, when we create one of these basic CRUDs, we'll specify something like an object, like a person, and that person type will be sent and to this T entity, or here again to this T entity, and set up there. I also have it here. It doesn't necessarily have to be in this where clause. I was trying something else, but you can make this specific, but we can also eliminate this here and just specify it in the main program. And so I have a generic object. I just created a person object and added it to the textbook code here. And it has an ID number, their name, and their date of birth. Yeah, it's just a really simple example of a record. And again, one thing that's kind of different is this GUID is something that's built into Microsoft libraries for giving you a unique ID. So like in the main program, if we're creating a new person, we can assign that person a name. Let's say we're creating a student, assign that student a name, and then GUID is again built into Microsoft, and we can just say new GUID and it'll include that. And then we can call our methods like our create and our read one methods based on this. And this just kind of shows the basic structure here, a little more detailed in the code in the book. So sometimes it's nice to see a fuller project here. And again, remember initially we looked at some of the decorators that added things on, like a logging decorator. And so this logging decorator added logging functionality here, and same with transaction. This transaction decorator added transaction processing to this. object. And so in our main program, we could, rather than creating a normal basic database, basic CRUD database interaction object, we could do like a transactional one and create one of those in a similar manner. There are some issues on this. This is a basic template. Not everything's working here. So in the example, we'll look at, or in your assignment, we'll look at a little more completed version of this. So let's return to the textbook then. So kind of an overview of where we're at now. We segregated our interface, so we have an iSave interface, an iRead interface, iDelete interface, and so we'll have objects that can create those. Now there's a couple ways of doing this. We can have multiple objects implement each, one implement each of these interfaces, or we could have one object that implements all three interfaces. So it goes through an example of an event publisher here. We're not going to go over this. There's some stuff here we're not going to worry too much about. Here, now down to client construction, we're going to talk about how we might set this up. The first way is to look at a class. So we're going to use a controller class here, which will set up, and we'll pass in a reader that will implement the iRead interface, a saver that will implement the iSave interface, and a deleter that will implement the iDelete interface, and set this up. And having this abstraction in here will make it easier to kind of use these segregated interfaces somewhat. So when we create this order controller, we'll pass in the objects we're going to use to do the reading, saving, delete, and we'll keep track of those. And then we're going to do have a create order method that will save the order, have a get single order that'll do things, update an order that will again use the saver interface, and delete that will delete an order for us. And again, now this is specific to an order, so rather than having a generic interface, we've created this specific to an order, just like we kind of did a person in the previous one. So now once we have this order set up, there's a couple ways of working with it. Now, so this controller here works specifically with orders and is set up just for orders, so we're calling it the order controller. But you could just similarly set up a generic controller. So here's a generic controller where we're specifying a generic entity. Again, we're using this template generic brackets here, greater than, less than. And so anywhere in here where we were saying order, we're now using that T entity object. So all this is set up to use those T entities in return. So then we could use this for any of a variety of different types of orders. Of things. So it would work for orders or for people or something like that. So here they're saying you might implement this for different interfaces. So now we've got either of these, either generic controller or the order controller, when we instantiate them, we have a couple options because they have to implement multiple interfaces, or we have to pass in these three objects that implement interfaces. So one way is to create a separate reader, a saver, and a deleter. So I have separate classes to do those, and when we call our order controller, pass in our reader, saver, deleter. So that kind of makes sense. We broke this up into parts, and we can have these as separate parts. So again, this is kind of called the multiple multiple implementations and multiple instances. We instantiate three different instances, a reader, a saver, and deleter, and pass them into the spots. Now, it is possible to create a single instance and pass that in. So here we have our interface here. Our object implements all three of our interfaces, our generic interface, and sets this up. So this is kind of our controller here that implements all three interfaces and creates this. Now, this is a class that does all three things for us, and so we could use this class to do all three objects. So we could use the same controllers up above our order controller, but create one of these more complicated objects and pass it in to be used as the reader and the saver and the deleter, and just use the same object for all three. So although we've segregated this, it doesn't mean we necessarily have to create three separate objects. Here we created three separate objects, but if we have an object still around that does all three parts, we can just create one of those objects and use that in all three slots, kind of. Now we do talk a little bit about some problems where we don't want to necessarily define a new interface that combines the old interfaces. We want to instead create objects that implement multiple interfaces. This kind of undoes what we just did as far as segregation goes. Um, Now, we've talked about decorators being one of the reasons for splitting an interface into smaller interfaces, which is what interface segregation is dividing it up. But there are a couple other reasons why, and the book just kind of goes through those quickly here. Um, might depend on what the clients need and want. So, particularly if you're working with multiple developers and one of your developers needs to use this interface, if it's one big interface, you might give that person too much control or access to too much functionality. So if you have it in the smaller interfaces, you can assign control a little better to this. And so we walk through an example of this. We're not going to go into this detail and worry too much about that. Another one is authorization. So maybe you have a database and you want to authorize people, certain types of users or class of users, access to certain functionality. Not everyone can delete a user or an order or something like that. And again, if you have a big interface, it's sometimes impossible to decorate or set up authorization for the different parts of it. So again, it's better to have an authorized a structure where your interface can be applied just to each individual part. The last thing is architectural. Um, Depending on how you set up your database and what you're using, you might have to divide things up in different ways. So here they're trying to break up this command query responsibility idea, where the reading will be done one way, and the updating and deleting will be done by another set of database commands. And in fact, in this case, they're talking about using one type of database, a Mongo database, for part of it, and another database for another part. I think they're looking at Hibernate. So again, it gets complicated here with one big interface, and so especially if you're using Hibernate for some of the commands and a Mongo database for some of the other commands. And so again, if it's broken up in different ways, you can apply the different interfaces with the different commands. It's just easier to divide up functionality either for authorization or for database interfaces and stuff like that if it's not one big interface. So it walks you through a couple of things. Now, in the end, you can end up with really small interfaces. Just have a single method in it, and some people actually like that. There are some issues with that, writing these generic interfaces in some ways. Um, so you might want to read and listen a little bit about that. But we're really focused on interface segregation, and again, taking this big interface, a big complicated interface like this, and breaking up into meaningful parts that we can then use.